Hello, this is Mr. Philippek, and today's video is a quick one just on what in fact is a Testcross. A lot of times this comes up in genetics when we're really unsure of what the genotype is of a dominant phenotype. And so when we look at, for example, let's say we have this. And in this example here, we have right here a purple flower. We know here that we will use the key that big P equals purple, little p equals white. Here we have our dominant flower, which is purple, but we're not sure if it is a big P or a big P, little p. And the way that we determine that is by conducting a test cross, where we cross this unknown genotypic flower that's showing the dominant trait with a true breeding recessive, or one that has little p, little p. And what we see here, we have two possibilities. If the genotype is big P, well, down here you notice that we end up with 100% purple. And that probably makes sense, because if the genotype is in fact big P, the only trait that this particular plant could pass on would be a dominant trait, so we would expect to get 100% purple flowers. Conversely, if the genotype is big P, little p, you'll notice down here that we get what we call it a 50-50 split between purple and white. And so we see that reemergence of this recessive phenotype. And so test crosses are real pivotal, especially if you want to know for sure, do I have a true breeding dominant plant, or do I have a heterozygous? And remember, if it's homozygous dominant, we're going to get 100%, just like it shows here, of the dominant trait. And then if it's heterozygous, we'll notice that we'll get a 50-50 split. The nice thing is that if you do get the 50-50 split, that you know for sure that the genotype of the parent plant is the same as all the offspring. Well, I hope this gave you a little insight on how test crosses work, and while you're working through your worksheets, I hope you reference this video and it really helps you out. And as always, thanks for listening.